tuples are sequences, but they are immutable sequences, meaning that they cannot be changed. Now, before I go on, I will mention that some people call these tuples, and some people call these tuples. And while there is no established convention for the pronunciation of this word, the two groups can at least agree that the other group must be wrong. I'll let you decide how you want to pronounce this word, but I'll say tuple most of the time, though occasionally you'll probably catch me saying tuple. So tuples are sequence values. 3, 4, 5, 6 is a tuple. See how we've not used square brackets, but instead parentheses. Though in fact, you don't need those parentheses at all in order to have a tuple literal. Anything separated by commas is evaluated as a tuple. A lot of people always put the parentheses around them just to be clear about what's going on. You can make an empty tuple. You can call tuple on nothing to make an empty tuple. Or you could call tuple on a list, or any sequence for that matter, and it will give you a tuple back with the same contents as that list. Now, what if you wanted to have a tuple with only one element? Well, it is possible to do that, and the syntax is just terrible. You have to put a comma at the end, and you can put that in parentheses as well if you want. So that's different from the number 2 in that this is a tuple containing 2, and this is just the number 2. Now you can add together tuples in order to get bigger tuples. You can use the membership operator to figure out whether an element is in a tuple. And you can slice tuples as well. Now, tuples are immutable values, which means it is possible to use them as the keys in a dictionary. Remember that it was not allowed to use a list as a key in a dictionary, because you get this error, unhashable type list. Now, even though you can use a tuple, you can't have a tuple with a list in it somewhere. That will cause an error as well. So tuples are immutable sequences, and immutable values actually have some benefits. One is that they're protected in a way from mutation. If I have a turtle, which is a sequence 1, 2, 3, and then I call some function called ooze, the turtle is going to still be 1, 2, 3, because this sequence cannot be changed. Numbers are immutable values as well, so are strings. The only mutable values, the ones that can change, are lists. So if I have this list, turtle 1, 2, 3, and I call ooze, just like we saw before, we might have anything in turtle at this point. Now, it's not strictly true that ooze cannot affect turtle. It can't change this value, but in next lecture we'll see that a function could change what the name turtle is bound to. So you get some protection, but not full protection in the language, from having functions make changes to your current environment. The value of an expression can change because of changes in names or objects. So a name change we've seen for a long time. If I have the same expression twice, x plus x and x plus x, we might get different values because the name x has been used for something else. So if I said x equals 2, then this would be 4. But if I said x equals 3, then x plus x would be 6. So those are name changes, and we've seen them throughout the course. Object mutation is different, but it can also have the same effect of changing what an expression evaluates to. So if x used to be the list 1, 2, then x plus x would be 1, 2, 1, 2. But if I append 3 to the end, then I'll get 1, 2, 3, 1, 2, 3 for x plus x. So these are two different ways in which the same expression can have a different value. And with immutable objects, this one doesn't apply. But this one always applies. You can always change the names of things. An immutable sequence may still change if it contains a mutable value as an element. So let's say I have a tuple that contains a list. Then I can't change the tuple. That's what I mean by immutable. but I could change the list within the tuple. So the tuple still contains the same stuff, but the list within it is different than it was before, because this 1 was changed to a 4. So as you can see, that's not that.